Okay, so in the second video here about inverses, we're actually going to algebraically be solving for them. And this is something that maybe you might remember from Hot 2 last year. And this is just a formal definition of what it means to be an inverse. So first of all, we have to make sure we're a one-to-one function. So, all right, the idea of being a one-to-one function is that any x goes to only one y. So when we do the inverse and try to undo it, that one y knows which x to go back to. Okay. And the notation of an inverse is this. It looks like it's an exponent and it's in the same position as an exponent, but in its context, it's not an exponent. It's the inverse function. And really all what we're saying is that if you do the inverse of the function, you would get back what you started. You're just undoing it. Or the function of the inverse, you get back what you're doing. So if my two operations are like multiplication and division, and I multiply by 2, right? So if my function is, let's multiply by 2 and get an answer. Let's do 5 multiply by 2, it's 10. And then let's do 10 divided by 2, which is the inverse function, it's 5. Right? So if you get back what you should have started with, then you know those are inverses. And that's all that's saying formally. Okay, but more in a practical sense, you just kind of do like a change of variable. Since you're switching x and y, since you want your y to become your x and your x to become your y, then you just do that, right, algebraically. So I'll go to a different color there. So instead of saying that this is y equals 2x minus 3, I can say this is x equals 2y minus 3. I just changed the position, right? I've just changed the fact that here's the x now and here's the y. It was there, and then I switched. Okay, so once you do that, now you just solve. Get y by itself. So I might add 3 to both sides and then divide by 2. And so whether you leave it like this or like 1/2 x plus 3/2, it doesn't matter. But since it's an inverse, we should probably use the inverse notation. So instead of calling it y, call it the inverse function, okay? Now, the thing is that in this particular function, it's a linear function, so the domain and the range are the same. So I don't necessarily have to, it's not too complicated to figure out for the function and for the inverse that the domain and range of each of them will be the same. So here's my domain, here's my range. So the domain of the function is all reals, which means the range of the inverse is also all reals because those x's and y's switch spots. Because that's the definition of an inverse. And then the domain of the inverse, which is here, is all reals because it's linear, which means the range of the inverse of the original function was all reals. So normally you'll see much more of a correlation. That's why I did it in colors, because those boxes will always be the same because you switch the x's and the y's, and these boxes will always be the same because you're just switching the x's and the y's. But like I said, here we don't necessarily see that difference. Okay, now next example. We have y equals the square root of x minus 5. And what I might do right away is actually look at the domain and range of that, right? So let's erase, let's erase this. So I have a little bit more space. And now in hindsight, I realize I didn't have to erase everything. I probably could just left the grid there, but that's okay. So we'll just keep working. Try, there it is. So not you. So I have g of x, which I'm given, and I'm trying to figure out the inverse. And then I have the domain, and I have the range, right? Okay. Well, right now, if I look at the domain of this, I want to make sure that I can't take the square root of negatives. So my domain of my function better be x is greater than or equal to, 5. Because that will allow that to be positive. X is greater than or equal to 5. That's the domain of my function. Now, even though I don't know what my inverse is just yet, I automatically know that because all you're doing is switching the x's and the y's, that the range, which is the y variable of the new thing I'm trying to find, will also be bigger than or equal to 5. Okay. Now, let's think about the output of a square root. when there's nothing in front of it, like there's no plus or minus, we're assuming it's the principal root, aka it's positive. So the outcome of this function is always positive. Worst case, it's 0. So the range of the function I'm given, right, the only thing that's coming out of this is positive numbers, which means that even though I don't know the inverse just yet, I know its x values can only be greater than or equal to 0. Those match, these match, right? Because all you're doing is switching the x and the y. So let's do it. Let's make this x equals the square root of y minus 5. So we have to get y by itself. So let's square both sides. And we add 5 over. Now, here's the thing. This is a quadratic function. And we just saw in the last video that unless you restrict the domain of your quadratic, you're not going to have a one-to-one function. But we can restrict our domain, right? Because right, you think about, what does this graph look like? X squared plus 5 is a parabola that's 5 units up, but we don't want the whole thing. Look what we said for our domain. We only want x's that are bigger than or equal to 0, which is that vertex value. So we don't need this side here because it's not part of the domain, because it wasn't part of the original range of the function. So now we're still a one-to-one function. So you might want to tack on your restricted domain. Oh yeah, x is greater than or equal to 0. Now it's still a one-to-one function. Okay. All right, let's look at the next one. Oh yeah, these are always fun. I like this. So right now, if I think about this function, so I've got k of x, and I'm looking for the inverse. So, and I have domain and range here. Domain and range. So right now I know that x cannot equal 26 because I would be dividing by 0. So x cannot equal 26, which means right away in the range of the inverse, even though I don't know what that function is, I know that y will not be able to equal 26 either. Okay, let's solve for the inverse. So this was a y, right? We can think of it as a fancy y. So y equals 3x minus 4 over 26 minus x. So let's make it x equals 3y minus 4 over 26 minus y. And let's solve for x. Sorry, solve for y. So we're going to multiply this quantity to the other side. So it's become x times 26 minus y equals 3y minus 4. We can multiply. So 26x minus xy equals 3y minus 4. And we need to isolate y, so we better put the terms together. So I might, I don't know, move this to the other side and move this to the other side. So I'm going to add 4 to this side. So 26x plus 4 equals, there's my 3y. I'm going to add this xy term over. And let's factor out a y on that right side. So 26x plus 4 equals y times 3 plus x as a quantity, because that's going to allow us to solve for y. So I'm going to need a little bit more space coming up here. So I'm going to get 26x plus 4 divided by x plus 3 equals y, or we relabel that as 26x plus 4 over x plus 3 equals the inverse. Now, this inverse function, I can now see right away what the domain issue is, right? The domain issue is that x can't be negative 3 because I'd be dividing by 0. So I'm going to come up here, the domain, x can't equal negative 3, which means in the range, I knew of my given function, y couldn't equal negative 3. But here's a hindsight. It was there the whole time, right? Think about this. Look at that. This is a function that has a horizontal asymptote at negative 3, right? Because it's 3x to negative x. So even then, I should have been able to know, right? Oops, right? Horizontal asymptote, y can't equal negative 3. And look at this. This has a horizontal asymptote of a ratio of 26 to 1. So it's 26, which is why on the inverse, I knew that the range y could not equal 26. Okay, so these are fun. I like these. So like in class tomorrow, we'll start here with this example, but feel free to, if you want to do that ahead, you can. And we'll look at example E as well in class. Like what happens if you have a quadratic there? And actually what I might do is actually make another video just because I like doing these. These are fun. So I think I'll do that. I'll go ahead and make one more video. So, okay. Good work on that video. And again, if you have questions, let me know. And we'll just go from there.